Hi, welcome to another video on the graph analytics series. So this video will focus on the subgraph algorithm. This algorithm purely focuses on one particular concept called a hop. Now, the subgraph functionality has two parameters. One is the source vertex and other is the number of hops. Now, if I run the subgraph functionality on a particular source vertex with the number of hops as 1, then it's going to result in an output data set which has all the vertices that can be reached from the source vertex by traversing one edge, or in other words, its adjacent neighbors. Now, if I run the same subgraph functionality on the same vertex with the number of hops as 2, then it's going to result in an output data set which consists of all the vertices that can be reached from the source vertex by traversing two different edges. Of course, this can be extended to 3, 4 hops, 5 hops until n hops, where n is any valid positive number. Now let's pick this particular vertex called LKO, and now we'll be running subgraph algorithms to find out all the vertices that are 3 hops away from this particular source vertex LKO. So let's go ahead and create a data flow and bring in after my data set. Let's click on add step and go and choose the graph analytics. And here we'll be choosing the subgraph operation. Let me hide the data pane. And if I jump into the parameters tab, it basically asks for the source, the destination, and the two parameters, which is what is the value of the particular source vertex. In this case, it's going to be LKO. And we will give the input as 3 for the number of hops. So I will not be using the reference columns. Now the output data set has the following columns. It has the source, it has the destination, it also has the hop number. So hop number is a column which represents what exactly is the hop number in the path from the source to destination. To explain it better, let's take an example. Let's say that we have a source vertex A, and if we have a path from A to B and then another path from B to C, A to B will be having the hop number as 1 and B to C will be having the hop number as 2. And I'm going to exclude the reference columns from the output data set. And then I'm going to click on Save Data. I'm going to give it a name for the output data set. I'll be using the same name for my table as well. The metadata for the columns, source will be an attribute, destination will be an attribute, hop number will need to be an attribute as well instead of a measure. Now I'm going to save and run the data flow. Okay, the data flow is saved. It typically takes 30 to 40 seconds for the data flow to complete its execution. Okay, so now the data flow is complete. This is the output data set that was created by running the data flow. So let's go and create a project using the same. So now we have the source, destination, hop number, and I'm going to view it in the form of a table. So we can see a bunch of source, destination, hop number values. But if we have to narrow it down to what are the list of vertices that are 3 hops away from our source vertex, then these would be the values in the destinations, which has a corresponding hop number as 3, meaning all these destination values are the vertices that could be reached from our source vertex by traversing 3 different edges. Now, this would be a lot more easier to comprehend if we view it on a network visualization. So let's bring a network visualization and let's bring in the source and destination columns, and we'll be adding the hop number to the link color. If we look at this graph, so we have the source vertex here, which is LKO, and the legend says that traverse all the edges that are painted in orange to find out what are the vertices that are 1 hop away. And then, in order to get all the vertices that are 2 hops away, follow all the light blue color edges, which are these edges, in order to find out hops that are 2 hops away. And finally, the dark blue ones are the ones which leads to vertices which are 3 hops away from our source vertex. So in this way, this visualization helps a lot in comprehending the output data set of the subgraph algorithm. This subgraph algorithm helps us to understand how well connected the source vertex is. Thanks for watching the video.